We're going to multiply two mixed numbers using two separate strategies. The first strategy is to convert both mixed numbers, it could be one or both mixed numbers, to fractions greater than 1, also known as improper fractions. We know with 3 and 4/5, the denominator is fifths. So 3 groups of 5/5 is 15, plus 4 more is 19, so 19 fifths. And with 5 and 7/9, the denominator is 9, so 5 groups of 9/9 is 45/9, plus 7 is 52/9. Now that we have them as fractions greater than 1, we can treat them like fractions less than 1 and multiply across. 19 times 52 is 988. 5 times 9 is 45. This is an answer. If you would like to convert it back to a mixed number, you divide the numerator by the denominator and you get 21 and 43/45. So with this strategy, you took both mixed numbers and converted them both to fractions greater than 1, multiplied them across, numerator times numerator, denominator times denominator, got an answer, a product that's a fraction greater than 1, then convert it back to a mixed number. So this next strategy, the mixed numbers stay the same. We're going to use the distributive property. With the distributive property, you're breaking apart your numbers into friendlier parts, or friendlier numbers, and multiplying those together, then joining everything back together at the end. So we're going to break up the 3 and 4/5 into 3, and then 4/5, and then separate the 5 and 7/9 as a mixed number into 5 wholes, and a separate 7/9 as a fraction. And when you're multiplying, you're going to multiply each part of this mixed number times each part of this mixed number. So let's start here with the whole numbers. And I'm going to write the expressions down below to show what we're multiplying. So we have 3 times 5. Then you would multiply 3 times 7/9. So let's write that. 3 times 7/9. And I'm just putting them in parentheses to keep them organized, the expressions organized. Next, we're going to take 4/5 and multiply it by 5. Then take 4/5 and multiply it by 7/9. So we broke each mixed number down by whole number and fraction, and then we're multiplying each part by each other for the other mixed number. So once you find the products for each expression, then we're going to add them back together. Now, as far as multiplying in these different expressions, at this point, students already know how to multiply each of these number cases. So they know how to multiply 2 wholes. They know how to multiply a whole by a fraction by a whole, and then 2 fractions together. Let's look for the product. So 3 times 5 is 15. 3 times 7/9. So when you multiply a whole by a fraction, you're multiplying the whole and the numerator and keeping that denominator the same. So that's 21/9. Same here, if the fraction comes first, it's still the same. Multiply that whole and that numerator. 4 times 5 is 20. Keep that denominator the same. Then when you multiply a fraction times a fraction, that's when the denominator can be multiplied. So we multiply across, numerator times numerator. 4 times 7 is 28. Denominator times denominator. 5 times 9 is 45. So now we can add these together, but wait, our denominators are different. A prerequisite for multiplying two mixed numbers using this strategy is that students should already know how to add fractions with different denominators. So let's continue. So we need to find a common denominator for these three denominators. So 9, 5, and 45, what do they have in common? They all have 45 as a multiple. So we're going to use an equivalent fraction to 21/9 and 25 so that they have the same denominator as 28/45. So this stays the same because the denominator didn't change. Here we're going to change this to 45 and this to 45. So let's look at how. So 5 times what is 45? 5 times 9 is 45. So we need to multiply 20 by 9, which is 180. For 21/9, 9 times what is 45? 9 times 5 is 45. So let's multiply 21 times 5. 21 times 5 is 105. Now, our denominators are all the same, so we can add them together. And let's remember we have the 15 as a whole number all the way on the left of our expression. So you can add 105 45ths plus 180 45ths plus 28 45ths together. You're going to get, and then add your 15, you'll get 15 and 313 45ths. Yes, this can be your answer. It depends on what assignment or a task you're working on. If it's a test, a lot of times leaving it this way is not acceptable, but this does represent the value of multiplying these two mixed numbers. But let's keep going if you need to show it another way. So this is a fraction greater than 1, again also known as an improper fraction. So we're going to take 313 divided by 45. Let's do it here. This part turns into 6 and 43 45ths. Then we need to add the 15 and the 6 back together. So let's rewrite it here. 15 plus 6 and 43 45ths equals 21 and 43 45ths, which is the same product that we got using the first strategy. So this strategy, doing it this way, does take longer for some, for most. That does not mean it's a bad strategy to use. If someone's more comfortable doing it this way, it is perfectly fine. It's down to a choice. So you have the other way, the first strategy we used where we multiplied, where we converted the mixed numbers into fractions greater than 1 and then multiplied. Here we use the distributive property to multiply each part of both mixed numbers. Same product though.